And now we are moving very quickly to our well, it's not really, it's a demonstration, presentation demonstration. And we are inviting from the Science Stories team that we started the collaboration this year only with Kenneth Seals-Nutt. So here we go. Go ahead.
Thank you, Maureen, and thank you for the Software Heritage and the PISA team for inviting us out here. I speak on behalf of myself as well as Dr. Kat Thornton, who's my co-collaborator who built Science Stories with me. And so instead of doing formal slides, I thought it would be fun to kind of step through a couple links that kind of walk through the tech stack of what Science Stories is, what Software Heritage implementation of software stories is, and kind of the decisions that we made along the way. So to get us started, I'll give just a quick 1-minute history on what Science Stories is, because I'm sure not a lot of people are familiar. Kat Thornton and I started several years ago on a mission to unforget the lives of women and people of color in science and throughout academia who were lost in the research that they were so pioneering across their industries that don't get their visualizations or children do not know about who they are, or young students don't know that their contributions to the devices that they hold in their hands. And so we thought this would be a great tool to give back and to retell in a more modern way a lot of the research that was done in the years past. And so we built Science Stories as a visualization tool, as well as a tool that allows you to build presentations that someone from the age of 10 years old up until a PhD student and a senior researcher could all look at the same website and still gain different types of information, but it still be accessible to them. So for example, this is one of the first Science Stories that we built for Grace Hopper, and who was an extraordinary computer scientist and one of the leading researchers and developers and founders of what modern computer science is today. And so here's an example of showing a image that we received from a research institution and got digitized. So this is an example of communicating with a direct archival institution and saying, this could be the first time this image is ever seen on the web. It could open the door to viewing for students to be able to view it, for people to be able to use it in a classroom, and to really understand what the technology is by learning about a person's life. And for example, you can see reports and documents. This is a fun one that is a drawing that Grace Hopper wrote, tracking the lineage of the computer. And you can zoom in and see various parts of this manuscript, as well as several other external sources to provide more narrative context as well. So that's a little bit about what Science Stories offers. And Roberto and team reached out to us when the swap process was getting started as a way to present a lot of the materials that were being curated and so meticulously saved and archived in repositories. And so we built software stories out of that and adapted what we did for scientists and also applying that to the software itself. This was a great collaboration between our organizations to be able to understand what makes it different to display this material for a non-human and still give a narrative and reach out to other organizations and collaborate with other types of media for this project. And so these are the three pieces of software that Carla just gave a great introduction on. And Thomas was the one that was in the video earlier today, so I'll go on to Softy and kind of just do a quick run through of some of the user interface here. And so behind the scenes, what's going on as the story is being built on the fly is a query out to Wikidata. And so when Wikidata when the Wikidata query runs, we're looking for all of these statements describing this piece of software, as well as the statements about this piece of software. So I'll go a little bit more into detail there in a second. Actually, here we go. And so this is an example of giving full text narrative, and this would allow a curator to provide full rich text editing if there isn't already a Wikipedia article for it. This is an example of the timeline. We can support images here as well as the dates. For software, this is an excellent way to demonstrate key features of a version history. And if you click the Learn More button, that will link out to software heritage directly at that timestamp using the software heritage IDs. Also presented in the video as well is a IIIF compatible viewer that is generated on the fly as well. Once the page loads, it'll reach out to Wikimedia Commons to stitch together a IIIF compatible manifest that will then show all of the metadata that our curation team would put inside of the image files and the files that we upload. If there's any media or publications about the software, they'll show up here in a very fun carousel that'll show it on a library shelf. You can learn a little bit more about it. Go out to, if there's a Wikidata or a other website, it'll link out to that website as well, so you can go right into reading the publication and learning more about it. We also have a map, so any geographic data that comes from Wikidata, we're able to pull in and map those geocoordinates on a map using OpenStreetMaps, and so you can kind of navigate through like a spatial view of the data that's available. This was. Let's just open the new tab. Okay, so one of the collaborations for software heritage that we did was expanding the software moment, one of our moments into a custom software heritage moment, and that would take in a software heritage ID and then can be embedded directly into the story itself. And so I'll talk a little bit about. So that's a presentation of the application, and then I'll kind of pull back the layers and kind of talk through what are the moving pieces that power this engine. So the first piece, if we're looking at the website, is a React Stories API layer. We developed this as a React component library that is open source. It's on GitHub, and will allow anyone to be able to download and build their own stories, whether that's through a data layer that we provide or a data layer that they want to specify by hand or even using JSON. All of the components are open source, and we'll have a full README for how to interact with each one. So on the main story component, here's an example of what it would look like to have a Wikipedia moment, a YouTube video, and then a Wikidata moment as well to embed the Wikidata page. This is the example of the two versions of the software heritage moment, where you can either give the software heritage ID, and then this will format the URL to properly embed and provide all of the permalinks in the interface, or you can give the full URL directly as two options if you have one handy and not the other. And then, but one thing about that is this could be a very manual process. If you were building a database or a presentation layer for hundreds of items, asking the front-end developer to build a React component for every single step in the story would be very arduous. So the next layer on top of that is figuring out a language that we can build a framework to generate this code. So the next step that we took on was creating a JSON schema that could map all of the data directly to it. And this is very overwhelming at first, but if you kind of break down what the steps are inside of it, you see the label that shows up. We use the Wikidata identifier as the main anchor for the Wikidata powered stories, and you can specify what the moments are, and then the data that goes into the moment itself. So, for example, if we want to input an iframe or the video itself, and then there's a section to give the URL for the video as an example. So now that once we build a way to generate this JSON payload, we then can build something like this. Oops. Something like this where all you need is the root component. So this is very accessible for someone that is not a front-end developer or doesn't have time to go through every single story and write the code for it. We would provide an API endpoint with the API key that will serve the JSON payload that I just demoed before, and all you have to specify is the ID to hit that API. And it's all wrapped in one centrally located React component. And so building web apps that are based off of this are about the size of this example right here, where the entire presentation layer is pulling from this one component. Taking one step backwards, so this is an example of looking at the JSON payload. I could update this in real time. For example, I'll update the description and then generate the story, and then you can see the update here. And this is the sandbox that we built so that you can preview the JSON payload directly. And this is one of the ways that we're able to build quick demos for collaboration projects and to be able to use this to ideate on what the future of the software should look like. Adding another layer backwards is how do we then get the data to then fill that JSON payload? So for that, we use the Wikidata query service as one of the main entry points to kick off the queries. This is an example of using the query service to write a Sparkle query on finding all of the software that have a software heritage ID that's in Wikidata. And so if we were to click on one, this is a very popular one, which would have a lot of statements on it. If you were just looking at this as a human, the idea behind how Science Stories works is it will pull every single one of these statements, as well as every reference that's in there, as well as if the value of that statement is another Wikidata item, such as this one, which it would have its own page. We'll pull in a shallow version of that data so we can display labels and aliases and determine what type of entity it is, as well as anything that mentions that piece of software in Wikidata. So thinking about, in this example, NumPy being the value on the end of the statement. So this is just an example of things that reference NumPy and Wikidata. So we would query all of those statements as well, and then in our data layer, we will then curate, or we'll create a Sparkle query for that. For this, we built a open source project called Django Wikidata API. Our API is a Django application, and so as our way to make sure that a lot of our translations are accessible and the innovations that we take for building the software is free and open source. We converted this into a Python package. It's still very early days as it's only supporting our package right now. So if there's any feedback, we'd love to take it. But the way that this package works is it will allow you to convert a Sparkle query into a Python object. So then Python developers can be able to use this, use the source code for this and extend it out without having to formally learn how Sparkle works or learn the Wikidata query service. So you can register which properties you want to look at of a Wikidata item through an ORM-like fashion, and it looks very similar to the Django REST framework API as well once it comes back. And yep,
1 minute.
1 minute, cool. That's actually great timing. Cool. So the last piece that I just wanted to show is with this work, there's a lot of moving pieces behind the scenes. There's a lot of room for automation, and so the future for this is to be able to make the acquisition process a lot more automated by building bots or by improving the way that we can ingest a lot of the data that comes in through the PISA collection. So this is our first open beta of the first 3 stories. And so yeah, feel free to click around in here, and if you have any feedback later today, feel free to reach out to me or Carlo or any other team. Thank you.
Thank you.